In this lab, we will show that for each band, compute the hash value for each document based on the R integers in the band. Contains a list of maps where each map has the hash value, has the key, and a list of doc IDs with the corresponding hash value. So first, we had found the optimal value of B and the optimal value of R. So we assigned 25 to B equal 25, that was the optimal value. And for band number in range B. So the range B will be from 0 to 25. So from 0 to 24 actually, not 25. So, and there will be 25 values in the range B. For band number in range B, let hash value to document list equal curly braces. Print hash value to document list. So we expect 25 hash value to document list to be printed. So you can see that 25 curly braces are printed, 25 pairs of curly braces. Then I want to show you this. For band number in range B, let hash function equal get universal hash function for integer list, and the input is number of docs, comma, R, print hash function. So here we are calling get universal hash function for integer list for each of the band numbers. So there will be 25 hash functions created. So this is the function that we are calling, and it will make 25 hash functions, and the integer list will be unknown. So print hash function, and that prints 25 hash functions. Now we have that signature matrix looking like this, and the length of the signature matrix is 100. So the length is the number of rows, and that is 100 rows. And if you want to find the number of columns, then we'll say length of NP dot transpose of signature matrix. And that is 3,480 columns. Okay. So next I will show you for band number in range B. So remember, the range B is from 0 to 24, and there will be 25 band number. And let band data equals signature matrix from band data times R to band number plus 1 times R, and then comma, and this empty space means everything for all the columns on the right. So let's print the band data. So okay, so what it does is that from the given signature matrix, which is this one, for example, the band number is say 1, 2, 3, 4. Say the band number is 4. So what it does is that it will, from the signature matrix, it will choose 4 times R. And remember, the optimal R value was 4. So band number times R, that will be row 16 to band number plus 1. So 4 plus 1 is 5. 5 times 4 is 20. So from 16 to 20. So these rows over here is from the signature matrix, row 16 to 20, 16, 17, 18, 19. And all the columns, all the integers in the columns will be included. So now for band number in range B, let hash function equal get universal function for integer list, number of dogs, comma R. Let band data equal signature matrix, bracket band number times R to band number plus 1 times R, comma, and all the columns, integers in the columns. Then let hash values equal np.apply underscore along underscore axis. So what this is a numpy function. So it will apply the hash function to all the values along the axis. So all these values will be put in to the hash function. So when we print this, let's print hash function, band data, hash values. Okay, so we can see that for the hash, so this will be done 25 times. So this part over here is repeated 25 times. So for the 25 hash functions. So hash function is this one, band data is this one, and the hash values are this one. So this is the length of this hash value is 3430, and the values in the band data is for each row we have 3430. So in the hash function, all those values in the column is applied. And yeah, and then it's printed. Let next for band number in range B. The range B is from 0 to 24. Let hash function equal get universal hash function for integer list. Input is number of dogs, comma R. Let band data equal signature matrix from row equal band number times R to band number plus 1 times R, and for all the values in the column for that row, for those rows, let hash values equal np dot apply along axis hash function, comma 0, comma band data. I'll just show you hash values, how many hash values are there, length of hash values. Yeah, so length of the hash values is 3430. So for each of the hash function, the length of the hash value is 3430. Now so we continue over here. Let hash values equal np dot apply along x-axis, along the axis hash function 0 band data. So we have already done that in the above. So okay, so in this one, in this function here, for band number in range B, so that is from 0 to 25, hash value, let hash value to document list equal Kelly braces. Let hash function equal get universal hash function for integer list. Input is number of docs and R. Let band data equal signature matrix from row band number times R to band number plus 1 times R, and for the values in all the column for those rows. Let hash values equal np.apply underscore along underscore axis of hash function, comma 0, comma band data. Print. So we want to print the hash function band data and hash values. Let's not print that because we have already done that in the previous. Let's print this hash value to document list instead. Print hash value to document list. So for document ID for each of these band numbers, now we will look for the corresponding document ID. So for document ID in range length of hash values, remember the length of hash values is 3430. So the range is for a range of 3430 equal range from 0 to 3429. So for the doc ID in 0 to 3429, doc ID equal to 0 to 3429 if hash values, so we have the list of the hash values like this in a one-dimensional array form. If hash values in that position, doc ID, so whatever the values are for doc ID, for example, doc ID equal 10, then hash values in position 10 in hash value to document list. If this hash value, so hash value 10, so for the very first hash band number, the hash function, so for the very first band number, the hash values are these. So if we choose, say we are showing, let's choose doc ID equal 10. So hash values in position 10, if it is in hash value to document list, that is in the Kelly braces, that is for the key value, then hash value to document list in that position, hash values in position 10, the value there. So hash value to document list 10 for the position of hash values where doc ID equal 10, we will append doc ID to that one. Okay, so if the key value if this hash values in position 10 is in hash value to document list, then in that position we will append doc ID. So we will form array, and in that position we will put in doc ID. Else hash value to document list, that position of the hash values equal array doc ID. So let's print hash value to document list. Okay, this gives us a little bit of error. So we are running out of this space. So let's put this as the print commands as comment, because we want to save space now. Okay, let this it's gonna take some time to print. Now this one over here, so let hash value to document list mapping per band equal empty array. Then for band number in range B, the range is from 0 to 25, let hash value to document list equal Kelly braces, and we have gone through all these previously, and then hash value to document list mapping per band. So after this loop, we will what we will do is this array that we have, we will append hash value to document list. And when we print in the end, if we print hash value to document list mapping per band, it prints like this in the array form. So you can see for the doc ID, for the doc ID 2, for the hash value 20530, we have doc ID 0. For the hash value 12986, we have doc ID equal 1. For the hash value 4239, we have doc IDs 212, 34, 68, 79, 99, 112, 125, 140, 147, 174, 186, 202, 219, 232, 241, 271, 280, 333, 376, 397, and so on. And then, yeah, and then up to the last number is 3421. And then so on. It continues. For the hash number 11809, hash value 11809, we have doc IDs 39 and 2408.